Hello everyone, you are welcome to today's class. Our topic today is gravitational field. We are familiar with the concept of force and field, but let's go over it briefly. Force is experienced in our everyday activities. In science, there are two types of forces, contact force and force field. Examples of contact force are push, pull, frictional force, etc. Example of force field are gravitational field, magnetic field, and electric field. Gravitational field is the weakest. Let's look at the word gravity. This simply means a force pulling every object to the center of the earth. Practical example of gravitational force on earth are 1. Gravity keeps our feet firmly on the earth's surface without floating away. Gravity causes objects like apples and raindrops to fall. The Earth's gravity holds our atmosphere in place, preventing it from escaping into air. The gravitational force from the moon and the sun creates high and low tides in the Earth's ocean. Gravity causes rivers and other bodies of water to flow downwards. Gravity keeps satellites, the moon, and the earth in their orbit. Our body muscles constantly work against gravity to keep it upright. Newton's law of universal gravitation. The foundational idea for Newton's law of gravity emerged in 1666 when he began to connect the falling of an apple to the motion of the moon and planets. Newton published his comprehensive work in 1687, which formalized his understanding of gravity as the force that governs the universe. A gravitational field is a force field surrounding every mass. When you have two objects in space, they will always attract each other, as explained by Newton. Newton's law of universal gravitation states that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This can be stated as follows. F is directly proportional to m1, m2, and inversely proportional to r squared. That means F is equal to G m1 m2 over r squared, where F is the gravitational force. G is the gravitational constant with a constant value of 6.67 times 10 raised to a minus 11 Newton meter square per kilogram square. M1 and M2 are the masses, and R is the distance between the two objects. Therefore, if either of the masses increases, the gravitational field strength will increase. And if the distance increases, the gravitational field strength will decrease. Let's take an example. The Earth has a mass of 6.0 times 10 raised to power 24 kilogram. The Moon a mass of 7.4 times 10 raised to power 22 kilogram. Calculate the force of attraction between the two if the distance between their centers is 3.84 times 10 raised to power 8 meters. Take G as 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. We'll be using our formula F is equal to G, ME, and MM. M is the mass of the Earth and MM is the mass of the Moon. We'll substitute in our values. That is 6.67 times 10 raised to power minus 11 times 6.0 times 10 raised to power 24 times 7.4 times 10 raised to power 22 divided by 3.84 times 10 raised to power 8 all squared. We'll collect all the numbers together. That means when you multiply 6.67 times 6 times 7.4, we will get 296 0.148. And when we collect 10 raised to power minus 11 multiply by 10 raised to power 24 multiply by 10 raised to power 22, we will get 10 raised to power 35 divided by 3.84 times 10 raised to power 8 all squared. We will square 3.84, that will give us 14.75. 10 raised to power 8 all square will give us 10 raised to power 16. So 296.148 divided by 14.75, we will get 20.08. 10 raised to power 35 divided by 10 raised to power 16, we will get 10 raised to power 19. So our answer will be 20.08 times 10 raised to power 19 Newton. Writing it properly, we will get 2.008 times 10 raised to power 20 Newton. That is our final answer. I hope you enjoyed the lesson. If you have any question, do well to drop them at the comment section below and I will respond to them as soon as possible. Bye.